Okay, this is a kind of unique thing, geometry and algebra together. We're dealing with matrices and scalars and how the algebra works when you're dealing with those. Now, like many other things on this exam, the idea of matrices and scalars is not intrinsically difficult, but it is a whole new vocabulary. So if you haven't seen this yet, haven't dealt with it, the concepts aren't difficult, but if you've never seen them, you could not have answered this question. So you just need to familiarize yourself with the nomenclature, with the concepts, with the ideas, and I'll show you briefly what I'm talking about. So first of all, matrices or matrices are nothing more than a set of numbers. They are put in, by definition, they go inside of brackets. So you will see them like this. That would be the left bracket and the right bracket. And then the elements that go inside of it can be numbers. They can be variables. Any number, any kind of variable you can represent inside of one of these matrices, which is set off by brackets like this. The matrix itself is identified with a large capital letter. So if this were matrix A, it would be like that. The elements themselves would be small. So if we had, let me just show you. Let's just put some numbers in here. So if this were 4, 14, -6, x, pi, and 0. First of all, this would be a 3-row, 1, 2, 3 rows. So you count down. This is the way I like to do it because it is defined as rows by columns. So I count down 1, 2, 3, and then over 1, 2. So this would be a 3 by 2 matrix. That's the way that you would identify it. 3 by 2 matrix. And to keep it straight, what you do first, normally it's easy to think you would start in the upper left-hand corner. That's where we start. A lot of Western civilization, reading, math, everything starts in the upper left-hand corner. And you go down and then over and count. And then each element inside the matrix has an identifier. So this is matrix A. So each element gets a small letter A, and for right here, its location would be first row, first column. A, so that would equal 4. A, first row, second column would be 14. So it would be this one. A2, 1, second row, 1, 2, first column, -6. That's how you can identify elements inside of a matrix. They're described as dimensions, rows, then columns. Count rows down, columns over. They are set off by these big brackets that you see there. They are identified with capital letters, and they can be any capital letter. You could have Z or anything else. And the elements have a location inside of the matrix. So if you had a 10 by 500 matrix, you would have a lot of elements in there, but each element has an identified location, and you do it just like with the coordinates of an X, Y. It's rows, then columns. All right, let's talk about manipulating matrices. And mainly this is addition and subtraction. And the way that you add and subtract matrices, first of all, they have to have the same number of rows and columns. So if you had two matrices like this, and they were both 2, 1, 0, 3, 0, 4, 1, 3. They were both 2 rows, 2 columns. So this would be, both these would be 2 by 2. The way you would add them is you add the elements that are in the identical position. So this position maps on to this position. So if you were to add these together, it would equal, this upper left-hand position is 2 plus 0. The next position is 0 plus 1. And then we have 1 plus 4. And we have 3 plus 3. So that's actually 2, 1, 1 plus 3, 1 plus 4, 5, and then 6. So this would be the sum of these two matrices. And then if we talk about multiplying, that's where this idea of scalars come in. So if we have a matrix and it is a 2 by 2, and let's say it's 3, -1, 0, and 2. And then there is a variable out here, not the name of it like a capital A or something, but let's say that it's 2, or it could be something else. It could be like 2x, and then you have to figure out what x is somewhere else. But once you reduce it down to a number like this is the scalar. This is what tells you what number you're going to use to multiply each position by. And you do it just like you would think. You just spread this across to each position, each element. So 2 times 3 is 6. 2 times -1 is -2. 2 times 0 is 0. 2 times 2 is 4. And this would be this matrix, this 2 by 2 matrix, that is multiplied by this scalar. That's the term you use for the number that you're going to multiply by out in front. I want to give you kind of a little example that kind of puts all this together before we answer the question. Okay, I just wanted to show you that you can treat these matrices like variables, and the multiplication is and the addition is done just like you would in regular math, as long as you have now got those basic principles in place that each position inside the matrix maps onto its corresponding position, and you add and subtract that way, and each position has an identifier location. So how would you solve this equation? 1/2 of this X matrix that we don't know what it is, plus this first matrix equals this second matrix. How could you solve for X? You can go ahead and stop it and figure it out and then come back and take a look, but I'm going to go ahead and answer it now. And the way you do it is basic algebra. So we have 1/2 of this unknown matrix is equal to this matrix here, or plus this matrix equals this one. So we can turn this first matrix into another variable and say that that is plus y equals z. So this matrix is now denoted as capital Z, and this matrix is now denoted as y. And we just solve this little equation right here. So 1/2 of this matrix, we're going to take y and subtract it from the left side, add it to the right, equals z minus y, and then we'll multiply both sides by 2, and we're left with this matrix equals 2 times this quantity over here that we don't know yet, z minus y. Now we have one variable, and we can solve this because we know what z here and y are. And now we plug them back in and solve it. So let's keep going here. We would have x equals, now I have to set this up, 2 times, this is going to be a quantity, and inside the quantity are these 2 matrices. So this first one is, this is the z, which is this one. So this will be 9, -2, -3, -4, 8, and 7. And like I said, these are not difficult, but there's a lot that you can mess up on because there's so much little things that you have to get right. So this was z minus y. This is our z. Now we're going to subtract our y matrices from that z, and it is 4, 2, 8, 7, 1, 6. Now, the way you subtract this is you subtract each position by its corresponding mapping position. So this 1, 1 position is you subtract 1, 1 from the 1, 1 position here. So the new, we're just dealing with this part right here. We're not dealing with the 2 yet. So let's just reduce this. This was z and this was y. Let's reduce this down to our new, what will be a new matrix called z minus y, and it will be 9 minus 4, -2 minus 2, -3 minus 8, -4 minus 7, -8 minus 1, and 7 minus 6. So you saw what I did. I just mapped each position with its corresponding position, and we had to subtract. So this becomes 9 minus 4 is 5. 2 minus 2 is -4. 3 minus 8 is -11. -4, -7 is -11. 8 minus 1 is 7. 7 minus 6 is 1. So this is our new z minus y matrix. And now we just have to multiply that using the scalar of 2. And we do the same thing. We just distribute it across each point, and that will equal our x, this new matrix. This will be our x matrix. And I'm not going to write out the equation or the multiplication here. Just 2 times 5 is 10. 2 times -4 is -8. 2 times -11 is -22. -22, 14, and 2. So this is our x matrix right there. Okay, so now let's answer the question.